Hello and welcome to the first video of what I'm wanting to be a game development tutorial series, and I mean game development from scratch. So in this series we're basically going to be going over the very basics. I'm not expecting you to know anything except basically how a computer operates. Another guy tried to make a series for this, but I don't think he went very far, so I've decided to make my own and sort of pick up in his steps. Again, you don't really need to know anything aside from basically how to work with your operating system. I am going to be using Windows 7 for this entire series. You should be able to follow along pretty much fine using Windows 10. If you're using Mac or Linux and you're having trouble, I'm assuming that because you're using those operating systems, you know how to work around the kinks and follow along on your own anyway. But if you don't and you come across a problem or something really weird happens, feel free to let me know in the comments, and I will do my best to tinker on with it in a VM or something to help you figure it out. So, anyway, to start, we are going to be learning, well, basically, if you're doing this from scratch and you're doing this by yourself, the thing that you need to understand is programming. And if you're new to what programming is, all it is basically a way for you to communicate with the computer almost directly, depending on what language you use. Technically, the only language the computer understands is straight binary, but the way we write said binary is different in these different things that are called languages. I'll get into that more later. But I'm wanting to make this as plug-and-play as possible. That way you guys can get straight into figuring out what to do. So, with no further ado, we shall go to Google. If you're wondering why I'm using incognito mode, it's simply because it helps me find search results with all my history messing with it. It's for research purposes mostly. Anyway, Google, then type in processing. And this is the bootstrapped language that we are going to be using. So click download, or actually, you know what? Just in case, if you look at this video in the future, I'll do this this way. So download processing. Now the one that you want to download, the one that is currently the newest that I'm using, just to make sure that there's consistencies. And as of now, this is the least buggy, and like your undoing doesn't mess with it. But yeah, in this series, I'll be going over the version 3.2.3, and my operating system is a Windows 64-bit. If you don't know what version of Windows or OS you're using, 32 or 64-bit, just Google basically how do I find, or you know what? Here, I'll show you. If my computer doesn't freeze up. Oh yeah, why am I downloading this again? I don't need to. I already did that. My bad. What bit is my OS? And there will be some instructions. You could say like, what bit is my OS on Windows or Linux or whatever, and you'll find your answers through Google. Anyway, yes, that's another thing you're gonna have to get used to, is looking stuff up on Google, because it's just kind of a necessity in this field of work, because there's a lot of research. Anyway, so after you have it downloaded, I've already downloaded mine, you would go to, give me a sec, you would go to where you have downloaded it, and where did I put it? Is it down here? There it is. So you would open it, because it's a zip file. In Windows 7 it should be fairly easy to open, and then copy it and then paste it wherever you would like. For me, for ease of use, I have basically pasted it in my desktop. That's simple. Now, it doesn't have an installer. Basically, it kind of works out the little extra, it works out its own installation once you open the file for the first time, kind of. It'll mess a little bit with your documents and update and all that. So yeah, just open it. And for your first time, it's going to take a little longer. I already opened this just for testing purposes mostly, to make sure that it works fine with my with me already having an older version of processing. So in here, again, it's going to freeze on you. Just let it wait out until it's done. But once it finally starts working, well, basically this is our programming IDE that we're going to be working in. And to start off, simply type this: void setup, parentheses, curly bracket, space, or enter down 2 times, another curly bracket. This is our setup function that shall run, or that shall be basically the first thing to run. So in here, we're going to give the size of our window. So 600 by 400 is 600 pixels by 400 pixels, which is 600 pixels wide and then 400 pixels tall. And then enter down a couple more times, and we're going to create a new function, which shall be our game loop. And processing determines our game loop by this: void draw. And if I remember correctly, the default frame rate is 30 frames a second. If you would like, you can very well say something like frame rate and then put whatever number you want in there for like 60 frames or 120 frames or whatever you want. I'm just going to keep it at the default. So to start out, we are going to create a rect. This is you know what? No, something easier. Ellipse. So we're basically going to draw an ellipse to the screen. Now an ellipse is simply a circle that can stretch out like an oval if you want it to. You know, it's like a rectangle for a square. A rectangle can be a square, but a square can't be a rectangle. Anyway, a ellipse at coordinates 50 by 50, that's 50x, 50y. We are going to give it a width of 50 and a height of 50. Oops, didn't mean to do that. My bad. So if we run this, we see that we have an ellipse here at well, by what I told you, it starts at coordinates 50, 50, which is right here, the very center of the ellipse. And then it stretches out 50 pixels by 50 pixels. Now this is, if I remember correctly, 50 pixels diameter by 50 pixels diameter. So it's not by radius, otherwise it would be twice as big. And it would fill up all the way on the edge of the window. Oh yes, I haven't explained the coordinate system. So to give you an idea, I'm going to change this to 0. So see how the very center of our circle or ellipse is at the very edge of our window? Well, that is the x0 coordinate. And if I tweaked this guy to 0 as well, you should be able to see that, oh, so the very so the 0, 0 coordinate is the very top left of our window. If you're a math buff and you want to, if you're a math buff, you should understand that this is what's called Cartesian coordinates. And just a note, I'm sure as heck not a math buff, but I have heard of this before. Anyway, Cartesian coordinates basically mean that your x and y start at the very top left, and the higher your number, the further down right you go, to the bottom right. It's a little opposite of what you're usually taught in math class, but give it a little while and this will rub off on you, and if anything, it'll make a lot more sense to you later on. So if we know that our window is 600 pixels wide by 400 pixels tall, then what if we change this to 600 by 400? Well, we would basically see the ellipse all the way in the very bottom right corner. Okay. And yeah, basically feel free to tweak these numbers and play with it. That's the best way you're gonna get this down in your head instinctively. So anyway, what if we want the ellipse to touch the very corner of our window, like hug up against it, but without actually going over it? Well, the best way to do it would be to take the size. So we know that it's 50 pixels. It's 50 pixels wide, 50 pixels tall, diameter-wise, not radius. Now, a radius is basically like half of the circle, and the diameter is like the full length of the circle. So to put this simply, in order to hug it up right against the top left corner, we would take the diameter, cut it in half, so this is the diameter, that's 50, so basically 25 pixels by 25 pixels. And that should change the location to where, yep, to where our circle or ellipse is hugging the very top left of our window. Perfect. If it doesn't make sense to you, play with this a little more, change these numbers, and kind of get used to the flow of it. If I were to have changed this to 100 and that to 100, then if you can't figure it out yet, these would basically be 50. And it would do the same thing. Now, that's basically it for this tutorial. I just want you to kind of... Actually, you know what? No. I'm going to go over something else. Yeah, another shape. So there's... when you're making games, you start out with ellipses and rectangles and maybe some triangles, and you kind of use them as placeholders for your sprites until eventually you get... until eventually you make your own sprites. But another common shape, like I just said, is rect for rectangle. And I'm actually going to get rid of this. So basically, it's similar to ellipse. The first two numbers you give it are the starting position. So the X starting position, I'm going to make 10. The next one, 10. And then I'm going to give this a size of like 20 by 20. So 20 pixels wide, 20 pixels tall. Now, the very top left corner of our rectangle is going to be the location of it. Unlike the ellipse, where the center of the ellipse is the starting position, is basically the position of the rectangle. Over here, the position of the rectangle is in the top left corner, and then it stretches out 20 pixels wide and 20 pixels downwards. So if we run this, it does roughly look like, yeah, it's about 10 pixels over and down, and then it stretches out about 20 more, okay? So if you want it to hug the very top left corner of the window, you would use something like 0 by 0. Excuse me. And there we have it. Okay, so ellipses coordinates start at the center, rectangles coordinates stop at the top left corner. Much like, in fact, how your window, how the pixel system in your window, basically 0, 0 would be the top left corner. It's a similar scheme for rectangles. It's like they're also related to Cartesian coordinates. So anyway, with this in mind, if you would like to change the background, what you typically do is in the draw loop, you would put a background and then one number or 3 different sets of numbers. So if we just put 0, that's black. Now, if you have any understanding of how computers work as far as like how the screen lights up, this may come as common sense to you, but for the rest of us, and for me when I started, let's give it 3 numbers for now. And let's say like this is 255. Now what you should know about this is that this is red, this is green, and this is blue. You mix these different colors between 0 to 255, and then the window will show you different results. So this is pure green. Now, if I were to have mixed red and blue, it should come as no surprise that this will turn out purple, right? Red, green, blue. Make sure you get that order down. So if we want to have a yellow window, you may be thinking, wait a minute, why red, green, and blue? Why not red, yellow, and blue? Well, because when you layer light on top of each other, it follows different rules than if you were to just simply put different colored opaque or clear-ish, like transparent objects on top of each other. Or if you were painting, this layering light on top of each other typically follows different rules. And analog TVs, if I remember correctly, were basically built on that concept, so even today we still use a similar scheme. So to create yellow, yellow, you would basically mix red and green. Little opposite of what you're used to, but yeah, and then you have yellow. Now if you mix green and blue, you do get like a greenish blue. Now to get a brown, I believe it's something along the lines of like you have to give it a sort of like a fractional thing. let me figure it out a sec. Yeah. I could be wrong, but this is how I remember. Basically, you would use twice as much red as you would blue, and you would use twice as much blue as you would, or not blue, I'm sorry, green. You would use twice as much red as you would green, and you would use twice as much green as you would blue. And this sort of ratio will give you brown. Also, a thing that I did not point out yet is why would this come out as black? And if I were to change these all to 255, it would come out white. Well, the answer simply is because this is the number itself resembles the intensity of light. If that didn't seem obvious at first. So if you wanted a gray, you would change all of these like so. And there's your gray background. Now, if you want, like if you know that your background's going to either be black or white or some sort of a grayscale in between, keyword grayscale, what you would, an easier method would simply be pass in one argument instead of having all three of the same numbers. This does the exact same thing. See? And I could change this to 255, and it's going to pretend that the red, green, and blue are all the same number. So pure white. There you go. So I'm going to keep that as 0 because I like to have a dark background to work with. I don't know, it just feels nice. Well, yeah, it gives a certain voidness to your world. That way it's easier to work with that, and my eyesight kind of sucks. I'm a bit light sensitive. But anyway, so if we wanted to change the color of the rectangle, we would use a function called fill. So 125. Okay, that should make our rectangle gray. By the way, the parameters you pass into fill are exactly the same as background. So if you had 3 numbers, it'd be red, green, and blue. If you had 1 number, it basically affects the red, green, and blue. That's all of them with that 1 number. So by this logic, okay, we put fill here. It should make our rectangle gray. Perfect. Now if we put, you know what, I'm just going to create an ellipse. Ellipse. Now you may be thinking, wait, wouldn't the ellipse turn white because the rectangle is originally white? Well, the answer is no. They would both be gray. Now, what you typically do, and processing at least, is that you would determine the color of the shape you're going to draw before you draw it. That's typically how you do it. Otherwise, don't define the color at all unless you want it to affect all of the shapes. So, to change the color of the ellipse back to white, or whatever you want, you would write fill right above the ellipse. So I could make this, you know what, I want to make it a green, just for the heck of it. There we go. See? Gray rectangle, green ellipse. Perfect. So the way that programming works, and remember this is our draw loop, so this loop runs once every 60 or 1/60th of a second or 1/30th depending on the frame rate. But yeah, it runs so many times a second depending on your frame rate. And when it runs, what it does is that it goes sort of linearly downwards as though you were reading. This makes it easier obviously for programmers to understand how their code works. So linearly going downwards, we go, okay, set the background to black. Okay, preemptively set whatever color of the shapes we draw after this fill to the value of 125, which is gray. And then in our rectangle, we draw it at the coordinate 0, 0, and give it a width and height of 20. Okay, and then set a new fill for whatever preceding shapes to green, and then, okay, then draw the ellipse, or this ellipse here. So this is basically how it works. Now, a thing I should also note is that you cannot, or you should not anyway, draw a background after you draw your shapes, because you will not see anything. The reason is because the background function kind of blitzes all of the pixels on the screen or on the window to be that one color. And if you've already drawn shapes beforehand, it's just going to run that right over those shapes as though it didn't matter. So the draw function not only happens linearly, but once the draw function has ended, whatever pixels have been changed will be blitzed to the window. So if we got rid of the background function entirely, it would naturally look gray. Now, usually you want to always have a background of some sort in the very beginning of your draw. I will go over that in the next tutorial when we cover things like animations. Believe it or not, it is quite easy to do. Which, at that point, I'll also go over variables and all that. So, yeah. Play around with these values, create shapes out of them. That's what my one artist friend basically started with. She made basically like a house using what was it? Using primitive shapes like these, including the triangle, which I'll just go ahead and show you for the heck of it. Triangle. You know what? And I'm going to get rid of these. The way triangle works is that you give it the first, or basically you give it sets of points. So 50 by 50. I'm going to put a space there just for, yeah. You know what? There we go. That'll make it look nicer. 50 by 50. Second point could be something like, you know what? Yeah. 75 by 75. And then the third point could be something like 25 by 50 or 75. There we go. Hold on, we got an error. The function triangle expects parameters like triangle, float, 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 float. Hold on, why is there 1, 2, 3, 4, 5, 6? Yeah, 6. 1, 2, 3, 4, 5, 6. Oh, I forgot the comma right here. Now, the reason why I have it spaced out like this is so it's easier to see what you're doing. You could very well get rid of these spaces and it'll work just fine, but I like to keep it separate, just so that it's easier to understand that when you draw a triangle, you work in points, more or less. So the first point is our 50-50. That's not good. Crap, looks like a glitch I'm gonna have to deal with. But our first point is 50 pixels wide by 50 pixels right, 50 pixels down, which is right here. Our second point is 75-75, which is the bottom right corner. And the last point is 25 over by 75 down, which is right here. So when you draw triangles, usually think of it as points, unlike the rectangle or the ellipse. Although I guess you could say when you draw the rectangle, you only think of 2 points. But anyway, that's beside the point. So knowing this, that'll fix it. So knowing this, you can now use ellipses, rects, and triangles to draw whatever picture you want. You can meld them together and make them whatever color you want, and then sort of, I don't know, make an interesting little sketch with it. Whatever you want to do. And then in the next tutorial, I'll go over animations and possibly basic collision detection anyway. And then after that, we'll see how it goes from there. So, good luck with this. Have fun. And I shall see you in the next tutorial.